This diagram outlines the ultimate goal of DevOps, an uninterrupted flow of value moving directly from the business straight to the customer. But right in the middle of that journey sits a massive roadblock: traditional, sequential quality and security testing. In a traditional setup, QA acts like a detective arriving at a crime scene. Testers have to manually create and manage test data, which creates a web of dependencies. The developers write the code, and then everyone waits for the testing phase to begin. This creates a paradox. Stacking more sequential tests into the pipeline grinds the entire deployment flow to a halt. As software scales, you need higher quality standards to catch fatal vulnerabilities before they reach production. Teams fall into a trap: bypass tests for speed and deploy risky code, stick to rigorous testing, and agility plummets. To actually achieve scale, you cannot simply shove more testing work into an old, rigid system. The pipeline itself has to be engineered to strip out the needless friction. One way to remove that friction is by changing how pipelines are built. Instead of letting every team write custom, potentially vulnerable deployment scripts, organizations use governed, reusable YAML templates. These are standardized blueprints that can be applied across entirely different workflows to establish strict uniformity. Within this setup, teams use what are called includes templates. If a developer needs a specific task, like a standard build process or a verified security scan, they don't write it from scratch. Pre-approved blocks of code snap right in, accelerating development. Then there are extends templates. While includes templates insert content, extends templates dictate the rules. They wrap around the pipeline and define the exact schema and logic the code must follow. If a developer tries to introduce an unauthorized task, the template simply bounces it back. These structures also come with internal guardrails. For instance, Azure pipelines enforce limits, capping template nesting at 100 levels and restricting memory consumption. This prevents the pipeline itself from bloating into an unmanageable mess. By enforcing these limits and structures, the pipeline mathematically prevents anyone from successfully executing a task that violates the organization's security policies. And because every pipeline now runs on the same governed architecture, you can collect standardized telemetry. Teams can instantly track build durations, pinpoint exact failure causes, and monitor compliance status in real time. Security is no longer a manual checkpoint where a human reviews a pull request. It operates as an automated architectural law built directly into the system. This slide illustrates the concept of continuous testing. Notice the large circular arrow wrapping around the cloud and gear icons. It signifies that testing is not a final, static phase at the end of the line. It is an automated loop embedded continuously throughout the entire development lifecycle. The philosophy here shifts. The goal of testing isn't merely to catch bugs right before release. As that returning arrow shows, the purpose is to generate instant feedback and amplify it directly back to the developer while they are still working. To maintain this speed, AI and automation take over the heavy lifting of data management. Instead of waiting days for someone to manually extract and sanitize production data, the system instantly generates realistic synthetic test data on demand. Validation happens exactly when the code is moving. Automated code scans and secret detection trigger during the pre-merge and pre-deploy stages, checking the work in real time. There is no more waiting for development to finish so QA can begin. The execution runs in parallel with the coding process. By integrating these automated checks and synthetic data feeds, you engineer the needless wait times out of the system. The deployment pipeline transforms into a self-testing, self-validating engine. When an organization adopts governed templates and continuous testing, the operational metrics clearly reflect the change. Lead times from development to production shrink, overall deployment frequency spikes, and defect detection rates rise. Quality is no longer a final hurdle on the right. It is a balanced priority spanning development and deployment. As noted here, standardizing tools across an enterprise requires a foundational internal development platform with clearly defined quality goals. True maturity in software deployment doesn't come from pushing code down a pipe faster and hoping it survives the trip. By embedding governed templates and continuous testing directly into the infrastructure, organizations bypass old compromises. They no longer have to choose between speed and security. They engineer a pipeline that demands both.